Hi there, my name is Marcel. I'm the author of the Mockifer project here. This tutorial is about creating a new controller that can be used to handle a request um, in the JavaScript application. So previous tutorials have talked about creating routes using the editor that just return sort of static responses. But if you need to do something that is stateful in nature, maybe it manipulates other pieces of data in the mock server, then you need to start writing those controllers in the JavaScript application itself. So in order to do that, we need to open up the Mockifer source project for the JavaScript application, and we use Android Studio to do that. So open up Android Studio and then choose Import Project, and just open up the root level of the Mockifer repository because it's actually a Gradle project in its own right. So I'll open that guy up. Okay. Right, so in the project view over here, there's a couple of items that probably need a bit of explanation. We actually have an Android project sitting in here. That's what generates the Android AAR library. It's not actually important for editing the JavaScript application. It just happens that it's also an Android or a project that can be recognized by Android Studio, so it appears in here. So you don't really need to worry about that one. You can have a look in there if you're interested. But this is actually the one that's most important, is the JS module. And under the JS module is a couple of things which I'll very quickly walk through. There's a resources folder with a few files that you might have seen in some of the previous tutorials. There's a routes.json. If you are watching carefully, there's the manifest and API.js. And I'll just quickly explain what they are. The manifest.json. So when Mockifer library itself bootstraps, it will read this file, this manifest file, and this will be a list of JavaScript files that it needs to preload in order to warm up the JavaScript virtual machine. So I've chosen to use Kotlin JS, mainly because I don't really like writing JavaScript directly, but using Kotlin JS means you can just write Kotlin code and it compiles down to JavaScript if you're using the Kotlin JS version. So this file here is actually the Kotlin JavaScript library, which is generated, so we don't write that ourselves. That comes out of the compiler. This one here, the Mockifer JS, is a result of us compiling our own code that we write, and we'll write a bit of code in a minute. And this one here is saying load this API.js file as well, which is a special file, and I'll open it up. Here it is here. And what it represents is the contract between the core engine over in C++ land and the JavaScript application sitting inside the JavaScript virtual machine. So the core engine will call these JavaScript methods when it needs to, and the expectation is that something on the JavaScript side will fulfill that, and that's where the contract is made. So this one here, for example, every time a request comes in and the core engine has decided what route to assign to it, it will actually call this method here in JavaScript and pass through the request and the route. And then we delegate that returning a response from this object here called Mockifer, which is actually the hook to our JavaScript application, and we call this method inside of it. And then it's up to that method inside our JavaScript application to return an appropriate response. And there's a few other methods in here that you could have a look at. This file almost never needs to get edited unless you're doing changes to the core engine, but just be aware of what it's for. One note about the manifests, I've chosen to use Kotlin JS, but because this manifest pretty much preloads any JavaScript files, you're welcome to write your JavaScript application however you please, as long as it will run within the duct tape JavaScript virtual machine. So if you want to use TypeScript, which compiles down, or if you just want to write just brutally plain JavaScript, you're welcome to do so, as long as you meet this API contract. Okay, in the data folder, there's a mock subfolder. So we've already seen this in the previous tutorials. These are all those mock responses that get canned. They're generated, so you typically don't edit them. But there's an internal area, and This is where you might put any data files that the internal server code might want to fetch. So for example here, I've got a list of cats, which this is actually where when the server boots up, it pre-populates itself with a basic set of data. And then after that point, that data is manipulated through server code. So you can use this internal area to store files. So we come up to the actual code base. So there's a core package in here. And there's a few classes in particular that are interesting. I won't go through everything, but I'll go through the core ones. The main one is the server. So the server basically just sits here and responds through this process request method. It responds back to the core engine. So the core engine receives a request, maps it to a route, and then calls this process request method through that API.js. And when it comes in here, there will always be a request. Whether or not it's well formed or not is another thing, but there may or may not be a route. So if the server wasn't able to work out what route to follow, this will, you can see here it's optional. So in Kotlin, there's optionals are first-class citizens, which is awesome. So we have these two pieces of information, and the server flow is basically this. It says, I'll try and create a request out of that JSON you sent me. If I can't turn that JSON into a request object, which is basically a class with properties, so if it couldn't parse it, this will take place instead, and then we'll just respond with a bad request and tell the user. Otherwise, it must mean we have a valid request. We step to the next part. Say, I'll try and take this route JSON and turn it into a route object, which again is an object like this. If I can't do that, then I'm going to respond back to you with a 404, which is what those codes map to. Which pretty much says, you know what, I don't know what route you're talking about. I can't do anything further. If we get down to this point, it means that we have a request and a route. And we look at the route and say, hey route, do you want to respond with just a plain old JSON file? And if you do, we're going to ask a built-in API to create a controller, in this case a JSON file mock response controller, and we'll ask it to respond to the request. So if we quickly look in there, so the way to respond to requests, at least in the default implementation, is through these things called controllers, and they all subclass a request controller. And really all that means is they have to implement a respond method. So in this case, when we were asked to respond with a JSON file response, we will know from the route which file to load. We kind of know what folder to look in because it's a mock file. We'll load that file. If we can't load the file, we'll return an internal server error. If we did load the file, we're just going to send back a response with the status code that came in with the root, or route. I think I've been saying route. I guess it depends where you come from. And the response body, which would have been the content of that file. And a response is just a plain object which has a status code, headers, and a body. And that would filter all the way back to the return statement, which then passes all the way back up into the core engine. If it didn't have a JSON file, we get to the next step and says, did you have a controller ID? And so the focus of this tutorial will be that we're going to create a brand new controller ID that doesn't exist. But if you already had one, it will say, okay, you've got one. I'm going to ask the current server session to create a controller based on that ID. So we'll hop in that code. This is it here. It says, I've got this controller ID. Make me a controller, please, that can handle this request. And if we reflect back on the cats.getAllCats scenario that we've been showing in the tutorials before, if it finds that matches a controller ID, we're going to return a getAllCats controller. And a getAllCats controller is over here. And it pretty much says, okay, well, here's a route, here's a request. I know I should react as though I'm getting all the cats. So in this case, I'm going to respond with success, which is a 200. And I'm going to create some response headers. And that just runs a bit of code, which asks the server session, create some headers. At the moment, there's just one, just a Mockifer one, but this is actually where you'd put your own headers if you had server logic that required that. It's up to you. And, wrong API, over here. And then as the response body that is sent back to answer to the original caller, we're going to have a JSON object with an object called cats in the JSON, and that cats is going to be populated with the content that comes out of server session cats repository get all cats. If I hop over here, gives me a list of these cat objects, and a cat object has an ID, name, and an age. And just to show you an example of the data that would actually return, it would look like this: cats, and each cat has ID, name, age. And that would be returned back formatted as a JSON string, and that's what would get filtered all the way back up. In the server, if it couldn't resolve the controller ID, it would get to this point and say, hey, even though I got a request and a route, something went wrong. I don't know what it was that went wrong, but I just can't reply. It's not, I couldn't find a way to do that. And then you get an internal server error instead. So what we're going to do is create a brand new controller ID that allows us to fetch something that doesn't exist yet. Now, one thing about editing the server code is when you've edited some code, you need to test it out somehow. And this little drop-down box up here is currently empty. That's because, unfortunately, Android Studio, possibly other IntelliJ products, when you import a project for the very first time, it seems to delete the .idea folder, which is also happens to be the place where run configurations are saved. So I don't know who made that decision, but it's quite annoying. So after you've imported this project, and you only have to do this once, hop back into the terminal, and you'll see that there's a little shell script called install run configurations. So we want to run that once. And all it does is it copies this run configurations folder from the support folder into the .idea folder run configurations. And if you come back into Studio, there we go. We've now got a list of all these run profiles. And these are really just shortcuts to all the Gradle tasks that we've seen before. But the important one is this one, run Mockifer editor. So normally you would write code in here, and then to try it out, you'd run the editor. So we'll do that now, run the editor. Okay, and this is the editor that you've seen before in previous tutorials. And we're going to create a brand new route. So we're going to call this one cars.getAllCars, and we'll just model this that we're going to return a list of cars back. We'll make it internal so this route is always active. Give it a display name, get all cars that we want. We'll do a get request. I'm not going to do tutorials for post, put, or delete. Have a look in the existing source code that comes with the libraries project to see examples of that with the cats and all that sort of stuff. But the request URI is going to be cars. And then the important part is down here, we're going to specify the controller ID, which means, hey, we want the JavaScript application to handle this request. So I'm actually going to just use the route ID as the control ID as well. So when this route gets picked up, it will try and find a controller with that ID inside the JavaScript application. I'll save that route. See, there it is in our list. So I can actually go into Postman and run it, and just ignore the data that was in there before. I was just testing something earlier, but at this point in time, even though we've called the URI, it did match to a route successfully, but we've got an error saying basically, hey, I found a route, cars.getAllCars, but I couldn't be executed. And I'll just close the editor and go back to the code again. And the reason for that is back in the server, we would have been given a valid request and a valid route. This would have been true. It would have had a controller ID. It would have gone into create request controller, and then it would look through these statements here looking for cars.getAllCars. But as you can see, there isn't one yet because we haven't made it. So then it fell back down to this catch here. So even though we've wired up the route itself in the editor, we haven't implemented the controller. So that's the next thing to do. So to implement our new controller, we are going to come up here, and there's a little APIs package. You can see there's the cats API that we've been looking at in previous tutorials. A cat is represented by a collection of properties, ID, name, age. It's basically what I refer to as a DTO, data transfer object. In this particular application, they're used a little bit as domain object as well. I guess it's up to you to decide how you want to structure your code. And we've got a cats API. And the API is just a list of controllers all about the API. So here we've got the getAllCats controller that I walked through earlier. So we're going to do the same kind of thing for cars. So I'll begin. Create a new package called cars. We want to model something that can represent a car. So make a new Kotlin class. Don't make a Java class. It's got to be Kotlin class, and we'll call this car. And I don't really need to know when this file was created for a demo. There's something to note, this JS name annotation, what it says is if this property here, ID is serialized out or is deserialized, it will use these as constant values for what to look for in the data. So if these properties themselves ever got name mangled, they would still resolve to the same elements of data. So I'm just going to cheat a little bit here and just copy because I don't want to make this tutorial too long. So a car is going to have, we'll just give it one property for today, and it'll be car name. Nice thing about Kotlin is you can have classes with no braces if that works. So there we go. A car is basically modeled as a thing that just has a name, just to keep it simple for today. And then we're going to create a cars API, class Kotlin, cars API. Again, you don't need to see that. And just in the spirit of time, I'm going to cheat again a little bit. And I'm just going to grab this guy and pop it in here. And you're going to be a cars API now instead of a cats API. And we'll call this method getAllCars controller. And what we want to do is basically respond with a list of cars. So here in the response, we're going to return something with JSON key of cars. We'll say cars is going to equal something. But in this tutorial, I'm not going to implement like a cars repository. Go and have a look at all the code to see how that works if you want to learn more. We're just going to inline create a list of cars for now, but this could come from anything. So we'll start off by saying cars equals mutable list of car. So we're creating a list of cars that we can add things to. So we say cars that add car, red car, and let's go with a green car and a blue car. Okay. So I've just created a little bit of data here. This could come from something that has more intelligence behind it, or that is more dynamic in nature. And probably if you're writing code in the JavaScript application, that's what you would probably want to do. And here, instead of doing cats repository getAllCats, we're just going to say cars to typed array. Okay. And then the response is basically going to answer back with success, which is 200. The default set of headers, which if you wanted to add more headers, you could do that. With a response body, it has an element called cars, and its value will be this list of cars turned into an array, because for JSON it has to be an array. And then ultimately the whole thing is turned into a JSON string. And that's what we get returned all the way back up into the core engine. So we've got our API, which is great. And we've got a new controller, which is also great. And we just need to wire that controller to that controller ID. So if we hop back over to our server, and again, this is where it tries to figure out what controller to use. We'll go in there, and we're back in this section, and we'll say cars API, cars.getAllCars. So if I see this controller ID, what I'm going to do is return cars API dot getAllCars controller. And we pass this because every controller needs to have the server session. Now the server session is like the state of the server, which is also the thing that gets reset if you do a Mockifer reset. Now that we've wired that up, with a bit of luck, we should just be able to run this, and it will compile a new code, and we'll see if we can hit it. So I'm just going to run the editor, which is how you compile this code and regenerate it. And pretty much what's happening is it will regenerate that Mockifer.js. And over to Postman. And there we go. So what's actually happened is this route with get/cars and a controller of cars.getAllCars, Postman has effectively invoked it because it found a match, and that controller ID filtered down into the server at this point. It came into this method here. It said, I've got this controller ID, what should I do? It found this match, cars.getAllCars, said, you know what, here's a controller that seems to match. Take this one. And when it found it, this question mark let means it will only run this line of code if the result was not null, which kind of means it found a controller. We just return whatever that controller was, respond to request. And in our case, we constructed a little set of cars here, and we sent back a response that was turned into a JSON string, and we sort of built this response up ourselves. Now this is a really basic example. In more complex code, and go and have a look at the CATS API for an example, you would manipulate stateful data in these controllers. At this point here, you could probably achieve the same effect with a static route rather than a controller route, but that's kind of the flow. That's probably enough for this demo because it's gone for quite a long time. Just to note that you can actually kick off all these other Gradle tasks now from within Android Studio if you want. And that's the normal workflow. So you would come and edit code and just run the editor to see it. And when that builds, the output of that would also be published into the products folder. And so all the other build targets would get those changes when you run these changes through the editor out of Android Studio. Okay, thanks for watching.